Swayam Prabha. Digital India. Educated India.
Welcome back. So, in the last lecture we just saw how to calculate the CV, that is the coefficient of consolidation, by using logarithmic time method. So, now today in this lecture we will be seeing another method by which you can also calculate CV. So, that is nothing but known as square root of time method. So, now what we do here? So, the square root of time method, basically we have the same thing, that is deformation versus root over time. Okay. So, we that is why the name is square root of time method. So, we plot the consolidation plot in deformation versus root over time space. Okay. So, root over time along the x axis. Now, basically what we are doing here. So, first step is that draw a line AB through the early portion of the curve. So, draw a line AB. So, this is the line AB. So, this is A, this is B. So, this line we are drawing, that is a straight line we are drawing. So, draw a line AB through the early portion of the curve. So, early portion means this is the say early portion. So, along that early portion, if it is tangent or the asymptotic. So, this AB is nothing but the line which is protruding out from the early portion of the curve, consolidation curve. Okay. Now, draw a line AC such that OC is always equal to 1.15 of OB. That means, OC is 15% more than OB, right. So, this what is OB? This is your OB and this is your OC, right. C is here. So, OC is always, we are drawing another line AC starting from point A such that OC is always equal to 1.15 of OB. Fine, there is no issue, very simple. The abscissa of point D, right, the abscissa of point D, what is point D? Which is the intersection of AC and the consolidation curve. Okay. So, you have drawn line AC and it is going to intersect the consolidation curve at point D, right. So, we are picking up that point D. So, the abscissa of point D is basically gives the square root of time for 90% consolidation. Okay. That means, I will be getting root over T90 from the abscissa of point D on the time axis, right. So, once you establish point D, immediately you drop a line, vertical line from point D, so that you get the square root of T90. So, once you get square root of T90, then basically the procedure is same. Now, for 90% consolidation, your T90 is equal to 0.848 from equation 4.36, because your degree of consolidation, average degree of consolidation is 90%, which is greater than 60%. So, you have got equation 4.36 to calculate the time factor TV, right. So, T90 is equal, you can calculate that and you can say T90 will be equal to 0.848. So, once you know the time factor at 90% consolidation, and that is nothing but 0.848. So, CV is not known to you. T90 just now you have got from the procedure, whatever steps you have just used to obtain T90. Okay. So, you have got root over T90. So, you can get T90, and of course, this is your drainage path. So, it will be remaining same whatever we have considered just in the next previous class, that if you have the double drainage system, the drainage path will be the half of the thickness of the specimen. If you have the single drainage system, then you will be having the drainage path will be the total thickness of the specimen. So, from this expression I can calculate CV equal to 0.848 HDR square divided by T90, right. So, for equation 4.38, as well as in the previous class we have seen, previous lecture we have seen how to calculate CV from logarithmic time method. So, any method you can use to obtain or to find out CV. Okay. So, now we will take couple of numerical problems, okay, on this consolidation, whatever we have learned so far. So, let us see the problem first. Okay. the problem says two soil samples A and B, each 30 centimeter thick, were tested in a consolidometer. The initial void ratios of A and B under a pressure of 1 kg per centimeter square are 0.6 and 0.65. Okay? That is the initial void ratio and respectively. So, they decrease to 0.505 and 0.605 when the pressure is increased to 2 kg per centimeter square. Okay? Now, to reach a 50% degree of consolidation, the time taken by sample A is 1/4 of that required by sample B. Okay? So, to reach 50% consolidation, that means the time taken by A will be 1/4 the time taken by sample B to obtain 50% degree of consolidation. Now, you need to compute MV, right, coefficient of compressibility, MV for both the samples and the ratio of coefficient of permeability of the two samples. Okay. So, you need to find out the ratio of coefficient of permeability. Now, let us start this problem. Okay. Let us see how to find out these things from this problem. So, problem 16. So, basically you are calculating MV of sample A. So, what was the expression of MV? Could you remember? Could you recall? The expression of MV was AV by 1 plus E naught, right, where E naught is the, what is E naught? E naught is the initial void ratio. Now, again you can write what is AV? AV was delta E by delta sigma, that is a ratio of change in void ratio to the change in pressure, right, change in pressure. So, into 1 plus E naught. So, of A. Okay. So, now let us identify these parameters. Do you know these parameters by the way? So, let us see that. In the problem, what is delta E? If you go back to the problem, delta E is said as, so initial void ratio of sample A was 0.6 when your pressure was 1 kg per centimeter square. Now, if you increase the pressure to 2 kg per centimeter square, then the void ratio decreases to 0.505. That means, the delta E is nothing but 0.6 minus 0.505, right. Now, what is your delta sigma? That is the change in pressure, right. So, what is the change in pressure? Earlier it was 1 kg per centimeter square, and this change in void ratio is happening by increasing the pressure by an amount 2 kg per centimeter square. So, so basically you are getting, that is your 2, that is the final stress increment, total stress minus the initial pressure. So, that is your delta sigma, right, into 1 plus E naught. What was E naught? E naught was 0.6, that is the initial void ratio for sample A. So, if you calculate this thing, you will be getting 0.059 centimeter square per kg. So, this is your MV for sample A. Okay. Now, similarly, I can find out the MV for sample B. How can I find out that? So, MV of B is equal to the same thing, delta E by delta sigma into 1 plus E naught. What is the value of delta sigma for sample B? If you go back to the problem, it is said that E naught was 0.65 for B and it comes down to 0.605, okay, with the increase in pressure. So, your delta E is equal to 0.65 minus 0.605 divided by the same increment of pressure is happening for sample B also, into 1 plus E naught, E naught is 0.65. So, if you calculate these values, you will be getting 0.027 centimeter square by kg. Okay. So, the first part has been obtained, that is MV for both the samples. So, you have got MV for sample A is nothing but 0.059 centimeter square per kg, whereas MV for sample B is 0.027 centimeter square per kg. Okay. So, now coming to the second part of this problem. Now, since both samples reach the same degree of consolidation, they have the same value of time factor TV, agreed, because you can calculate, if you once you know the degree of consolidation, average degree of consolidation, then you can find out TV by equation, by the equations whatever we have obtained. So, if your U, that is the average degree of consolidation, is 0 to 60%, you have got one equation or expression for calculating TV, and if U is greater than 60%, then you have got another expression for calculating TV. Anyway, so if I talk about same degree of consolidation for both the samples, that means it is in the problem, it is given the 50% degree of consolidation, okay, that is the matter of concern. So, if both the samples are experiencing the same degree of consolidation, or I mean if we are concerned for same degree of consolidation for both the samples, then of course, our TV will be same, right, from the equation whatever we have seen in the last lecture. Anyway, so we can write CV A by CV, what is CV? Coefficient of consolidation, is equal to TB, that is the time, by TA into H dr square for A, H dr square for B, right. I hope that you remember TV is equal to CV T by H dr square. So, that was the expression we have derived earlier in the lecture, right. So, now what we can get? So, CV by A, that is the ratio we are calculating. So, CV A is the CV value of for A sample, and CV value for B sample is CV B, is nothing but equal to, from this expression basically, because your TV A and TV B both are same, right, because you are thinking about the same degree of consolidation. Okay. So, from this we can write, so CV A by CV B is equal to, now what is TB by TA? So, that is given in the problem. So, if you see the problem, to reach a 50% degree of consolidation, the time taken by sample A is 1/4 of that required by sample B. So, TB by TA is nothing but 4 by 1, okay, multiplied by H dr square A and H dr square B. So, that is nothing but, I mean if I consider that I mean in the consolidometer basically what you do, you put the porous stone on top as well as the bottom, right. If you put the porous stone at top as well as the bottom, that means this is a double drainage system, am I right. So, water will be expelling out from the top as well as from the bottom. So, your HDR square will be why 30 centimeter was the thickness of the sample. So, 30 by 2 whole square divided by 30 by 2 whole square. The thickness of the sample, both the samples is same. So, from this I can get CV A, the ratio of CV for sample A and for sample B is 4. Okay. Now, therefore, I know that, do you remember this? I mean, if you recall that thing, that CV is equal to K by mv into gamma w, right. So, long back, I mean, in the previous lectures we have derived that, or we have got it. Okay. So, CV is equal to K by mv into gamma w. So, if that is true, so I can write Ka, that is the coefficient of permeability of sample A divided by coefficient of permeability of sample B is equal to CV A mv A into gamma w divided by CV B into mv B into gamma w. So, if we put the values, so 4 into 0.059 divided by 0.027 is equal to 8.71 is the ratio. So, that means the ratio of coefficient of permeability of two samples, that is Ka to Kb, is nothing but 8.71. So, we have done the, or we are done with the problem. So, now basically you have seen we have used this logic, because your TV must be same for both the samples, because you are thinking about same degree of consolidation for both the samples. And so, the TV is obtained from this expression, I mean this expression will give you the value CV, and again CV can be obtained from this expression. So, you can calculate the coefficient, I mean ratio of coefficient of permeability. Now, we will take the next problem. So, next problem says that an area is underlain by a stratum of clay layer of thickness 6 meter. The layer is doubly drained and has the coefficient of consolidation of 0.5 meter square per month. How long would it take for a surcharge load to cause a settlement of 50 centimeter if the same load causes a final settlement of 60 centimeter, right. So, basically in that problem you have one clay stratum, okay. So, which is experiencing some double drainage system, that means it I mean water can go out from the top as well as from the bottom. The thickness of the stratum is 6 meter and the coefficient of consolidation is given. Now, basically the thing is that that stratum will be experiencing 100% degree of consolidation, right, at 60 centimeter, I mean settlement, right. The problem, I mean it is given in the problem. If the same load, that means you are increasing the load, you are putting some surcharge, if the same load causes a final settlement of 60 centimeter. So, when we are talking about the final settlement, that means it is the settlement corresponding to the 100% degree of consolidation. That means, when your U, capital U is equal to 100%, that means your soil or the stratum will be experiencing 60 centimeter settlement, right. Now, if the strata is experiencing 50 centimeter settlement, then what will be the degree of consolidation? This is very simple, right. So, I can calculate the, so problem 17. So, your degree of consolidation for 50 centimeter settlement is nothing but 50 by 60, right. So, which is nothing but 0.833, which is nothing but 83.33%, very simple, right, because your 60 centimeter settlement is your final settlement. Final settlement means when you will be getting 100% degree of consolidation, then only you can say this is my final settlement. So, 60 centimeter is the settlement at the this is the final settlement at u equal to 100%. So, what will be the magnitude of u at 50 centimeter settlement? That is nothing but 83.33%. So, that means if the soil is if the degree of average degree of consolidation is 83.33%, then the soil will be experiencing the 50 centimeter settlement. Okay. So, this is the only tricks in this problem, other things are pretty straightforward. Okay. So, if you have degree of consolidation u equal to 83.33%, then you can calculate TV, right. How you calculate TV? Because your u is greater than 60%. So, which equation you will be using? So, that you have in the lecture 1.781, if you look at 933 log 100 minus u in percentage. Okay. So, if you put this 1.781 minus 0.933 log 100 minus 83.33. So, this will give me 0.641. So, your TV is equal to 0.641 at 83.33% degree of consolidation. Okay. So, once you know TV, you can find out CV, which is nothing but TV HDR square by T. Okay. So, TV just now you have calculated 641. Now, what is HDR square? You are getting double drainage system or the doubly drained system. Okay. So, your total thickness of the stratum is 6 meter, that will be divided by 2 whole square, right, because the water can go out from the top as well as from the bottom, divided by the time. Time is given, I am sorry. So, time is not given. So, CV is given rather. Okay. So, this is the expression. So, from that I can write T equal to CV, which is nothing but 0.641 by 6 by 2 whole square divided by CV is how much? 0.5 meter square per month. So, 0.5 meter square per month is your CV. So, once you get all those things, you will be getting 11.538 months. That means, the stratum, that clay stratum of 6 meter thickness will experience 50 centimeter settlement, okay, in 11.538 months, okay, if other things are remaining as it is. Okay. I will stop here today. So, in the next lecture, we will try to take some more examples, more numerical examples to understand the consolidation in a better way, and then we will move to the next topic. Thank you very much.